Welcome to the online lectures for software engineering. In today's class, we'll be studying the topic software product metrics. Now, what is a product metrics? Or we'll see what are the different examples for product metrics. If we take examples in a everyday life, if we take example of a college experience, so what are going to be the metrics? College experience, so examples of metrics from our daily life. Now, within the college experience, the first metric can be what are the grades that you've received, can be in the last semester. Then, what are the number of classes that are taken each semester? How much time you spend in the class? And this can be the amount of time that you've spent on studying or doing homework this week. How many hours of sleep did you have last night? So these are a few examples of metrics. If we take examples within daily life, it can be cost of utilities for a month, how much rent you're paying. This can be a few examples of metrics. Now, why do we have software product metrics? Now, this software product metrics, it is going to help the software engineers so that they can better understand what are the different attributes of the model. This is the first thing. And the second one is so that you can also assess the quality of your software. Now, this helping the software engineers with the understanding of the attributes and assessing the quality, this is going to give you insight into the design and the construction of the software. It also helps when focuses upon some specific attributes. As you're understanding the attributes, you can focus upon some specific attributes of the software engineering work product, and from that you can get a analysis, design, coding, and testing part. Then what is software quality? A definition for software quality is the conformance to explicitly stated function and performance requirements. Now, what are these? Now, the three important points. The first important point is your explicitly stated software requirements. Now, this explicitly stated requirements, these are the foundation from which quality can be measured. That is what is what quality software that you have developed. Now, if you have got lack of conformance within the quality, then that if you've got lack of conformance within the requirement, that means there is lack of quality. So here, lack of conformance to requirement means there is lack of quality. So this is the first important part. Then coming on to the second important part, that is your explicitly stated development standard. So this second part, this is your standard. Some specific standards are there that are going to define how you're going to develop a particular software, in what manner. So there are some development criteria that is going to guide you how a software product is engineered. Now, if this criteria is not followed, then again lack of quality is there. If criteria is not followed, this again means there is lack of quality. Then coming on to the third important part, That is an explicit characteristics that are expected for all professionally developed software. So the third important part is your implicit requirements. Now these implicit requirements, they are often not mentioned. Now a few examples of this can be the ease of use. That is the software that you're developing, it should be easy, flexible to use by different customers. So these are often not mentioned. So if the software conforms to the explicit requirements but it does not conform to the implicit requirements, then again software quality is a suspect. That is again, it is not met. You should be following the explicitly stated requirements and also the implicitly stated requirements. The next is the McCall's quality factor. Now, this McCall's quality factor is going to provide a practical and up to date method for classifying the software requirements. Now, this quality requirements, these are split into 11 software quality factors, and these 11 factors are grouped in three categories. Now, what are these three categories? Product operation factors, product revision factors, and product transition factors. Now, within operation factors, you've got correctness, reliability, efficiency, integrity, usability. In revision, you've got maintainability, flexibility, and testability. Whereas in transition factors, you've got portability, reusability, and interoperability. Now, within this, we can see in detail about each and every aspects here. The 11, your 11 factors. Now, this is your McCall's quality factor triangle. You've got product revision, transition, and operation on three of the sides. Now, what is correctness? Correctness is going to tell you that it should give you correct output whenever you're executing a particular program or a query. It should give you the correct results. Then the next is reliability. Now, reliability is that how much can you rely on the software, that what is the how do you get to know that that software is giving you accurate results? What is the precision in which the software is computing the output? Then you've got efficiency. Efficiency is how efficient the software is. That is the amount of computing resources, the code, how much is required by a program to perform its function. Then you've got integrity. Integrity means whenever you're developing a particular software, the software should maintain integrity. That is, if there is some specific information uh, that requires some specific login to access this file, then it should open those files only on authorizations. Then you've got usability. Usability is how efficient the software is. That is how much you have to learn to work on the software. So there is the effort required to learn to operate the software, prepare the inputs, and interpret the outputs. What input should be given and what output can be expected. This all comes under usability. Then maintainability, as the word says, maintainability, how you're going to maintain the software. That is, if there is a bug, how you're going to fix that particular bug. That is the effort required to locate and fix it. You're going to find it out and then you're going to fix it. Then you've got flexibility. Now, flexibility is the effort required to modify the operational program. How flexible the software is. That is, you've got some changing, you you gotta make any some changes within the configurations, whether those configuration settings are acceptable by the software or not. Then testability, the effort that is required to test the program to ensure that it performs the intended function. That is, within the previous class we've studied about testing. So testing is done so that you get to know that whatever functions are there within the software, whether they are working well or not. That's testability. Then portability is how efficient the program can run upon different environments, on different operating systems. That becomes your portability. Then you've got the reusability. The reusability is the extent to which a program can be reused in other applications. Now, a program is made up of different parts of source code. Now, the source code can also be used by another program that has that specific feature. So that is to what extent this program can be reused within other applications. Then interoperability, that is your effort required to couple on system to another. So when you're using one system along with the another system, that is interoperability. So these are the 11 factors of McCall's quality factors. Then you've got the ISO 9126 quality factors. Now, this quality factors, you've got functionality, reliability, usability, efficiency, maintainability, portability. These are your ISO standards. From the 11 standards that we studied within McCall's, this becomes part of your ISO 9126 quality factors. This standard is developed so that you can identify the different quality attributes for the software, in which these are taken from your McCall's factors. Then coming on to the framework for product metrics. Now here you've got measures, metrics, and indicators. You've got three different terms. The definition for three different terms is what is a measure? Measure, it provides a quantitative indication of the extent, amount, dimension, capacity, or size of some attribute of a product or process. So you can say that measurement is a process of collecting one or more data, and you can say that when you've got multiple components are there, when you've got multiple components and you're reviewing all these components and you're also testing all these components individually so that you can collect the measure of the number of errors that are there in all the components. So this become your measure. Then next comes the measurement, that is the act of determining a measure. Then the metric is a quantitative measure of the degree to which a system, component, or process possesses a given attribute. So metric can be defined again as a quantitative measure, and metric allows a software engineer to identify if the efficiency is going to improve the quality of the software product or not. Then you've got indicators. Indicator, it is a metric or combination of different metrics that is going to provide you insight into the software process of a software project or the product itself. So this is your three term with the four terms: measure, measurement, metric, and indicator. Then you've got the goal oriented software measurement. Now, within the goal oriented software measurement, you've got the GQM technique, that is your goal question metric paradigm. Now, this GQM technique, it is going to identify the meaningful metrics. It is going to identify what are the different meaningful metrics for any part of the software process. Within the entire software process, what are different meaningful metrics that is going to be identified by the GQM. Now, this GQM emphasizes the need to for two things, that is establish the explicit measurement goal. Explicit goals mean that are mentioned, that is specific to the process, activity, or product characterized that is to be accessed. Now, that is within GQM is going to identify metrics within the software process. So this is going to establish one explicit measurement goal within any software process that you're working on. Then the next is define a set of questions that must be answered in order to achieve the goal. Now, whenever you know what the goal is, you need to make it clear by asking a set of questions. That is what needs to be attained, what needs to be achieved, how it is going to be achieved. So that is your designing a set of questions, and they need to be answered to fulfill your goal. That is why the term itself is the goal question metric. Now, this GQM utilizes a goal definition template to define each measurement goal. Then the attributes of effective software metrics. Now, what are different attributes within the software metric? The first is it should be simple and computable. That is, it should be relatively easy to learn. And how to drive the metrics, that should also be again simple. It should not demand any effort or much time. That is why the term simple and computable. Then the next is empirically and intuitively persuasive. That is, the metric should satisfy the engineer's intuition notion about the product attributes under any consideration. It should satisfy the engineer's intuitive. The next is consistent and objective. That is, the metric should always give you results that are unambiguous. That is, it should not have more than one meaning. The results should be unambiguous. Then it should be consistent in the use of units and dimensions. Now, units and dimension means it is talking about the mathematical computations of a metric that you're going to measure, that is going to give you a combination of different units. That is like in measurement you've got different units, so you should be consistent in the use of units. One time you're using one measure, another time you're using another measure, one time you're measuring in mLs, then in liters. That is not acceptable, so you should follow one unit at all times. Then programming language independent. Now you know programming language independent. Then an effective mechanism for high quality feedback, that is the metric should give you a higher quality product. The end product, it should be a high quality. Then product metric taxonomy. Now there are few metrics for the analysis model also. That is, the functionalities should be delivered. That is, it should provide an indirect measure of the functionality that you're packaging within the software. Now, this becomes your functionalities that are delivered. Then one of the metric is system size. That is the system size. The measurement of the entire system should define in the information available as part of the analysis model. That is, what is the size of system? It means that how much information is there within the software. Then specification quality. The specification quality, it means that what provides an indication to specificity and completeness of the requirement specification. So this becomes your specification quality, how you're indicating the specifications, the completeness of your requirements. Then you have the metrics for your design model. Now in the metrics for design model, the first one is your architectural metric. Now within this architectural metric, it provides the indication of the quality of your architectural design. So architectural metric means what is the quality of the architectural design that you develop. Then the next one is your component level metric. Now this component level metric, it is going to measure what is the complexity of the software components and also of the different characteristics that are based on the quality. So this component level metrics means, as the name suggests, component, it is going to identify the complexity, that is how complex the particular software component is. And if suppose apart from the component, there are also some characteristics that are uh, that have a main focus upon the quality, you're also going to identify the complexity of those different characteristics also. Then you've got the interface design metric. Now this interface design metric, this focuses upon usability. That is how much you need to learn to work upon the software, what inputs should be given, what output can be produced. That is your usability. Then the next one is specialized object oriented design metrics. Now these specialized design oriented metrics, this means that you're going to measure the characteristics of classes and how they are going to communicate. That is, there is, if you've got a class has got three compartments. Now these classes are connected via links, or these are called as your relationships. So this is going to measure the characteristics of your classes and how they are communicating via the relationship. So these are your metrics for the design model. Then coming on to the metrics for your source code, the first one is your complexity metric. Now this complexity metric, it is the measure of the logical complexity. But as the source code means, you're going to measure the logical complexity here of your source code. Then you've got length metrics. Now, length metrics means within the source code, you're going to identify what is the size of the software. Based upon your size of the software, you can have the length of your software code depends. Now, these metrics can be used to access the source code complexity, maintainability, testability. So these characteristics can be used for identifying these three things: source code complexity, maintainability, testability, among your other characteristics. So within these all different characteristics, you can identify these three also. So these are your metrics for source code. Now these metrics, all these metrics are important. Then comes the metrics for testing. The first metric for testing is the statement and branch coverage metrics. Now, this testing means you're going to focus upon the different test cases, how the test cases are designed. Now, statement and branch coverage means it is going to lead to the designing of those test cases that leads to how much coverage is there for the program, whether all the components are covered, whether all specifications are covered or not, sub specification is covered or not. That is you're connecting the statements, and if there are any branch to it, whether all of those parameters are tested or not. Then you've got the defect related metrics. Now this defect related metric, this is focusing upon the bugs that are found rather than testing. So then the next is testing effectiveness metric. Now this testing effectiveness metric, this is going to provide you as testing effectiveness means this is your real time indication of how effective the test is that you have conducted. Real time indication of the effectiveness of the test that you're conducting. So that is your testing effectiveness metric. From the name itself, you can write it down. Then the last one is in process metric. Now in process means this is going to focus upon all your process related metrics that can be determined as your as testing is being conducted. So within in process means as the process, as you're doing the as you're doing the testing, you're going to identify the metrics of the process. So this becomes your metrics for testing. So these are the different metrics for testing.